Okay, so today's video is going to be about maximum and minimum problems, and more specifically, it's going to be how to solve a maximum and minimum problem. So I'm not going to go over any actual specific examples of how to solve these problems. I'll do those in the following videos, but what I'm going to do is going to be conceptualization of what these problems are going to consist of. So if you have some sort of function that's f of x, some x, and you want to know what your absolute maximums and minimums and your local your local minimums and your local maximums are going to be, well, you need to understand what these are. So let's say our function makes a shape kind of like this. Draw an asymptote in right here. So we won't worry about what happens on the other side of that red line. So if you look here, you can see that obviously we have some boundaries, maybe some a and b, so we have an interval here. So on a closed interval, there's always going to be an absolute minimum and an absolute maximum, and in this it's pretty obvious where those are going to be. It's going to be right here at your lowest point and right here at your highest point. Okay, but there's also going to be local minimums and local maximums. So if you look at parts where you're going to have, so to further explain this, at the parts right around here, what are called, these are going to be your local mins and local maxes. And what these represent are parts where the derivatives of your function are going to be equal to 0. So in this case, there are examples where your absolute mins and maxes could be the same as your local mins and maxes. But your local min and max could never be, for example, something like this here, because, well, the derivative there doesn't equal 0. It's just cut off by an asymptote. There's a boundary there, right, because we're on a closed interval between a and b. So in spots that f of x is going to equal to 0 is where this is going to happen. You have a tangent that's flat. So in places like this, now this is pretty important, these are going to be where your critical numbers are. Let's call those C. Because what happens now is that when you solve for these critical numbers, this is going to tell you where you're going to have these local mins and local maxes. So what's going to happen is that when you solve for critical numbers, and you do so by setting the derivative equal to 0, you solve for the function, and you solve for when this x function here, whatever is going to allow that to equal 0. So two ways to define critical numbers by definition is where the min and max of the function are located. So what it is when the derivative is equal to 0 or it does not exist. So this is points where it could be at our intervals as well. So at our a and b, we could have derivatives that don't exist there because it could just be a sharp point or something. It could be a non-continuous function. So, and what you do next is, once you've found those critical points, define the actual value of that maximum minimum value. You're going to take those critical points C and you plug them into that derivative to give you some number. So what you do is that you're going to plug in what you get for A, what you get for your C's, and what you get for your B's, and those are all going to give you some numbers. And what's going to happen is that you're going to just analyze those numbers and you're going to see which ones are your biggest and which ones are your smallest. And your largest one is going to be your absolute maximum and your smallest one is going to be your absolute minimum value. So that is the overall idea of how you solve one of these problems. See the next video on how to solve for the actual critical points.